Okay, before we begin, this class is sort of a split class. It's meant to be a split class. If you are not sure about what to do about the BlackJack game, maybe you've turned in the design, maybe you haven't, maybe you have turned in the design but are just struggling at what to do to implement it, and so on. This class will be focused on trying to give you some ideas and trying to get you moving in the right direction as far as that goes. So you're welcome if you're close to being done with Lab 7, or you have a start on Lab 7 and you're pretty happy with it, or you're pretty confident you know what you're doing, or you're done, or you're almost done, you're welcome to just go in the lab and continue to work. All right? So if you're not, I'm going to assume that you want this sort of little bit extra assistance on this. So you're welcome to stay or you're welcome to go. Okay? I'll just give you the opportunity to do that. I hope I have my thumb drive's plugged in. Well, again, this is optional. All right, this is an optional lecture. You're welcome to work in lab if you are making progress on this, because this will go over stuff that if you've completed Lab 7 or you're close to completing Lab 7, this will go over stuff that we probably have already that you've already addressed. So you're welcome just to go to lab and work on this, on the assignment. I don't know if it will be a full lecture or not, but here we go. What I did is I wanted to strip this down because the standard idea and the standard philosophy in any kind of coding often is take a big problem and break it down into smaller problems. Okay? That's usually, what we go for. So what I've done is I've created two classes, all right? A deck and a card class. And I've created a very simple interface to test those classes out. So if you're not sure about the design, or you're not sure once you have the design what to do with it, I hope this will be instructive for you. Now, keep in mind, this is not a complete solution. My thought is we might just continue with this approach and have split classes where people can work on their stuff, or they can come to lecture as we talk about more detailed stuff. But we can play that by ear. We'll see how well this works and go forward. So let's look at what I did create.
Is this uploaded?
No, it's awkward to upload it because this is kind of giving away the answer, or at least part of the answer. So I'm a little bit torn about uploading it, and I haven't uploaded it yet. I don't know. I'll have to decide. Maybe if you ask specific questions, I can load a method here or there, But I'm hesitant to load the application because that's giving too much away, I think. All right. So here's what I have. And notice, when this finally does open up, what this has and what it doesn't have. It has a card a deck, and a main activity. All right? That is some, but not all of the classes. All right? Some, but not all of the classes. Eventually, there will need to be a rules class that has things like how do you score a blackjack hand. A player class. Anything else? Oh, a recycler view. But I want to keep this simple, and I want to focus on just a few things at a time. So there's not even a recycler view in this one. All right? Which I hope makes it a little easier to understand, because the recycler view is among the most confusing bits of code that we have. But it's very good code to understand and be able to use. But again, it's hard to make that leap and understand everything all at the same time. If, for example, we can get and understand this piece of it, then our next question is to, well, how do we incorporate a recycler view on it? Then we're fighting one battle at a time. All right? It's just, we could talk about military examples, where you're fighting battles on different fronts. A lot of times that doesn't go very well, right? If you could focus your efforts on one attack at the same time, attack one aspect of the problem at a time, you're going to be much better off than if you're trying to attack a bunch of things at a time. Like I've said before, it's better when you're done to have one simple thing working than to have 10 simple things or 10 complex things, none of them are working at all. All right? It's better for your attitude. All right? It's better at the end of the day to have something that, like, I can deal cards and they show up on the screen. That's not the whole blackjack game, all right? But at least that one piece of it you've addressed and you've handled it. Now, can you make it better? Sure. Is there more stuff you have to do? Absolutely. But at the very least, you have one piece of it done. So let's look at what I have here and what I have in the application, and there's some key things. And this is something that we can build on. And maybe we'll do a few lectures like this where we'll build pieces of it at the same time. All right? I'm going to focus on two things, the layout and the Java classes. Let's look at the layout. I have two layouts. All right? One of the layouts is a very simple GUI with just some buttons that says take a hit and reset. That's it. So there's two buttons, a hit button, a reset button, and I have a scroll view. A scroll view is kind of my, what will I say, less powerful version of the recycler view. All right? We're going to add things to it.
Would you recommend, Mike, I don't mean to interrupt you, would you recommend that we use a scroll view for this assignment versus a recycler view?
I'd rather use a recycler view, but it's one of those things that, how do I want to say it? There's always a compromise between, the quote, best way to do something and practical concerns. I would prefer that you learn how to do the recycler view, and my hope is that after we do a few examples of this, that the recycler view won't be so scary. Because we're going to do everything but the recycler view today. Not everything, but we're going to do a big piece of it today without the recycler view. So my plans are right now, anyhow, when we look at this again on Tuesday, we're taking this and we're adding a recycler view to it. That's it. Maybe another class. So hopefully if we can do it that way, we can build to it. So my bottom line is, can you turn it in without a recycler view and get full credit? Yeah. probably can. Would it be better for you to take and make a little bit more effort and get the recycler view to work? Yeah, probably yes to that too. And I'm hoping we can get to that point. All right? But at any rate, that's the approach I took. Got a scroll view. So, real simple layout. Linear layout, button, button, scroll view. I then have a single XML file for a image view. This is going to be the view that's going to get inflated for each card. Now, when we go and we take this and we make a recycler view out of this, we're still going to have this, right? We're still going to inflate it. We're going to do things a little differently. It's going to be a little bit different code here and there, but the basics of this is going to be the same. All right, we're still going to have our image view in this XML file. All right? Because remember, that scroll view, we don't know how many cards there are. It's not like we're going to put 5 cards in there, or 8 cards, or 4 cards, or whatever. There's as many cards as there are cards. Every time we deal a card, there's one more card. So we make it flexible so that we can add as many cards as we want to it. So that is our 2 views. In our simplified world, this image view is going to get inflated and added to the scroll view. In the more complicated view that we'll talk about next week, about the same thing's going to happen, except an adapter is going to handle this, and it's going to add stuff to the recycler view. All right? So let's look at our classes. I have a deck class. A deck class consists of what? It consists of an array list of cards, right? And if you think about it, that's what a deck is, right? A deck is a list of cards. It's a list because the cards in a deck are in a certain sequence, right? Especially, after you shuffle them. The top card, and that sequence matters, right? Because we're dealing in order. We're taking the top card off and dealing it as the next thing that we're dealing. It's an array list because the number of cards varies. We start out with 52, but every time we deal, there's one less card in the deck. So it's not going to be an array, it's going to be an array list. And it's going to be an array list of cards. One of the mistakes a lot of students make is they think, well, I'm going to make an array list of like a string. And the string will be like maybe the face value and the suit combined, or something like that. No. If we want, a deck isn't a collection of strings. A deck is a collection of cards. Our card models mimics the real world. It's interesting that this doesn't always work, so don't consider it a hard and fast rule. But a lot of times if you think in real world terms, well, what's in a deck? A list of cards, a collection of cards. Well, then you have a card object, and your deck is a list of those. What methods do we have on this? We have a constructor. Doesn't require any arguments. All right? Doesn't really seem to need to be any arguments for the constructor of a deck. And we call a method that says initialize deck. All right? I'm actually seeing a little... Oh, interesting. We also have a refresh deck method. This is if it gets to be less than 11 cards, it starts with a clean deck. You don't have to worry about that one. And what does this do? this goes through and it creates a card object inside of a nested for loop. Okay? You don't have to put this in its own function. You can put this right in the constructor if you want. Why is this 0 to I less than 4? Why does that first loop go through 4 times? What does that correspond to? 4 suits of cards. Right, there's the clubs, hearts, spades, and diamonds. Why does this go through 13 times? Yeah, the face value, there's 13 of them. 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, queen, king, ace. So there's 13 of them. And the way I have it set up is the suit is indicated by a number and the face value is indicated by a number. We can peek inside the deck or the card class to see what that is. Because I have a static string array that contains the names that go along with this. Alright? So the suit name, hearts, diamonds, clubs, spades. Card name is 2, 3, 4, 5, 6, 7, 8, 9, Jack, King, Queen, Ace. I can't make this an integer, right, because Jack, Queen, King, and Ace are names, right, or string names. Alright? So the 0th, so if a card had a subscript of 0 and 0, it would be the 2 of hearts. So that's what happens in the deck. I have 2 for loops. The first one starts off with I equal to 0, and then the inner loop executes and makes j go from 0 through 12. So that first trip through the loop creates all the hearts. Creates a 2 a heart, 3 a heart, 4 a heart, 5 a heart, all the way through. The second one, iteration through the loop, the big loop, creates all the diamonds. Then finally clubs and spades. Notice what I do. I create a new object, right? I create a new object because actually it's like I'm printing cards, right? So each time through the loop I'm printing a new card and I'm giving it the suit and the face value. If you notice in the card class, the constructor accepts 2 arguments, a suit and a face value, the name of the face value. And I set those 2 values, and they're both integers. So, after I run the constructor on the deck, the constructor calls this function, it makes 52 cards in my deck. I then call the shuffle method. A shuffle method is a method that accepts an array list and does the shuffling for you. So you don't have to worry about shuffling the deck. That will randomize the deck. I also have a get next card method. You could call it a deal method, right? Because this is getting the next card. When you're dealing cards, what card are you taking off? You're taking off the top card. So that is the card with a subscript of 0. Top card is a subscript of 0. All right? I'm grabbing a reference to that card. Okay? I'm grabbing a reference to that card. Why? Because I need to put that card in someone's hand. Alright? Need to put that card in someone's hand. So I need a pointer to that. Because the return value from this function is going to be a card object. Right? So when I get the next card, what do I give? mean, it's mimicking real life. The dealer gives someone a card. Well, we're giving them a card object. What does this line do? Card remove next.
Takes it out of the stack.
Takes it out of the deck, right. Okay? So we grab the card, and by grabbing the card, we take it out of the array list. So we are not going to deal the same card twice. And then we return that card. Okay? We return that card. Now let's look at the card class. The card class has a couple of static arrays. What does a static array mean? Does anyone remember what the static mean?
A predefined list that does not change.
It does not change per object. In other words, this is defined, a static variable is defined, or a static method is defined on the class level and not on the object or instance level. So in other words, I can refer to the suit name without even looking at a card. I just ask for the class associated with this. This is useful because I need to put together the image name of the card. And the image name is going to be the suit and the card name. In fact, if we look at our resources in Drawable, I lied. If we look at our assets, there we go. We have a folder for each, and that might have been the confusion about putting it in folders. I put it in assets and not folder and not resources. I have a folder for each suit, gets the name of the folder from this, and gets the name of the image from the card name. Now, let's look at the main activity. Are there any questions about these two classes? The card and the deck. Really not a lot in them. Alright? There is a and you know, if you're not comfortable with the Android controls and you want to create a deck class and a card class and just run a unit test to create a deck, deal out so many cards and display their name, go for it. Alright, that would be a way to test it, and then we can incorporate that into the Android app. I'm talking about like if you're, remember like what we did in the Intro to Java class, where we just write a little test class to create a deck, get a card from it, display that. Alright? Okay, questions about either the deck or the card class? Alrighty. Now, let's look at the main activity. Main activity. I defined a linear layout for P hand layout. This is my simplified version of the recycler view. Because instead of adding to the recycler view, I'm just going to add to the linear layout. And we'll find that's going to be a lot easier than the recycler view. I have two buttons, reset and hit. I create my application. I grab pointers to the hand layout. I grab a pointer to the reset button and a pointer to the hit button. I then set two listeners, a listener for the reset button and a listener for the hit button. Those listeners are defined as inner classes. They're not anonymous classes, they're inner classes. The reset button handler is over here. and the hit button handler is over here. So I have my two listeners for the two buttons I have. I initialize game. Initialize game creates a new deck and removes all of the children that were already in the layout. This is where the fun starts. All right? The method to give a player a card. Now that happens when I click the hit button. Give a player a card. What does that do? Well, it's going to get the next card from the deck. All right? Get the next card from the deck. I need to display that card, which means I need to create a view to display it, which means I need to inflate my card XML. And that's what this two lines do. I create an image view that I'm calling new card, and I create it by inflating the R layout card XML. Again, why do we do this? Because we need to create one of those every time we hit the hit button. So every time we hit the hit button, we go through this routine of creating a new image view that eventually we're going to put in our scroll view, our linear layout. So, I have a pointer to my image view called new card. That's the new image view that corresponds to the new card. This is one way to get an image. There are other ways. This way uses the assets and streams the value of the asset. I form the name of the asset by combining the suit, a slash, and the name, .png. Right, because if we look in these assets, the 2 of clubs is in the clubs folder, 2.png. All right. I then create a drawable object by creating an input stream, reading in that file that has that name, and I set that new card image view to that drawable object. And then I add it to my layout. Let's see what time it's going to be. 5:50? Is that right? 10 to
Yes.
10 to 6? Okay. Excellent. Okay. So when I run this is what I get. Hit. Clear the game, hit. Clear the game, and so on. Questions about this? Now, let's say I don't really understand the Android part of it yet. Maybe the Android part is confusing. I mention about the Java part. Let's just work on the Java part then. So what you could do is you could come up with a card and a deck class and create that in Java. Sort of like what I did with the pizza classes, right? If you remember, I gave you those pizza classes. Those pizza classes were straight out of Java 101 or whatever it's called, Java 226. So I could take these classes if I wanted to. You could develop them. I'm going to create a new folder called Java. I'm going to paste these guys in here. Then I could create a test class. A unit test. That. I don't know how to make this bigger. I'll go in. Unit test. Public. Static. Void. Main. Accepts string arguments. And I could do something like this. Deck D equals new deck. Let me get rid of this package stuff. Card C equals deck get next card, I think it's called. Yep. In fact, I'll put it in a loop. Equals 0. I less than 52. I plus plus. We're going to deal out all 50 cards. And then I'm going to print the card, get suit and get name. Where's that gap? That close deck. I could go into terminal. Java folder, Java C star.java. Forgot a semicolon apparently. Or not. Oh, forgot the parentheses. Boy, I'm not doing so hot today. And then I can run. If I did this right, I should see all the cards of the deck in order. Not in order. All the cards of the deck not repeating, but in the order in which they were shuffled in. I shouldn't see any duplicate cards and all that. So I guess what I'm saying is I hope that, how do I want to put this? I hope that no matter where you're at, there's something that you can do and think about. So even if you're totally unsure about the Android stuff, which we can work on creating the card and the deck class and test those in a similar manner than this. All right? Get that down. Then we'll look about hooking it into the Android application. Okay? So I don't want you spinning your wheels. I don't want you trying to do everything all at once. Pick a piece of it. Pick the size piece that you think is appropriate for where you're at, and let's work on it, and let's gradually build up to being a complete application. All right? Questions about any of this? All right. That's all I had. If you have questions about it, if you think questions about it afterwards or whatever, like I said before, I'm torn about posting the whole thing simply because, the fact that this is part of the actual assignment. But if you want to see a function or want to see a piece of it or have questions about that, feel free to ask. All right, we'll see you over in lab.
Is this lecture going on?
The lecture will go up, yes.